So let's start with generative models. You're all familiar with this. These are also known as LLMs, large language models. You might hear them called foundation models. What can they do? What are they? Well, I'm sure everyone here has used it. Has everyone tried ChatGPT? Pascal already covered this. Everyone's tried this. It's literally in the name. So ChatGPT is a generative pre-trained transformer. It's a generative model. They pre-trained it on the entire written contents of the internet. And it's a transformer architecture. That is a Google research paper published in 2017 that then Google didn't really do much with, and OpenAI figured out how to use. So, of course, the classic example, writing emails, right? Let's write a client email. I'm going through the month-end close. I'm taking some notes and bullets. And here I've asked it, I've told it you're a friendly, helpful, knowledgeable accountant. Please draft this into an email. And I want to point out one thing before I show you the results. I have separated the two prompts, right? I have given the model a job description, and then I've given it the input. You do this so you only have to write the job description once, and then for every client you have your bullets, and boom, it spits out an email. And honestly, the email's quite good, right? You could polish this up, send it off, and great, move on. So generative models are fun. You can use them for a bunch of things, but to me, they're probably the least interesting part of AI. So let's move on to some really cooler stuff. Let's talk about agents. So here, we have another example. Can I afford to hire 20 engineers next year, assuming their salary? And look at this agent. OK, it's going to go calculate. It's going to check your net income. It's going to compare this. And then, oh, based on our cash position, I'm sorry, no, you can't afford to hire 20 engineers. Actually, it turns out maybe I could hire 10 or so. Well, what's going on here? This is interesting. It looks like a generative model, but all of a sudden, there's no job description, right? I can just ask it a question. And it can do math. And it can access my data. Wait, how is this happening? The way agents work is super interesting. It's an LLM under the covers. It's a generative model. But you give it all of this help. And so the person building the agent writes this job description that needs to be quite extensive. And so it basically, here's who you are. Here's what you can do. Here's what you can't do. For example, you don't want your accounting agent dispensing dating advice. That could get awkward. It takes the task. That's what the user input. And then you also give it a whole bunch of tools. And this is where the power really lies. These tools are old school classic computer programs, things that the model can then call. And so you could look up your chart of accounts. You could run a P&L. You can research how hiring an engineer works. You can give it a general calculator tool so it can do math. And the JD tells the agent, tells the model to basically make a plan, use the tools, evaluate the results, and then did it succeed? Is the task complete? If not, go back to the beginning and keep trying. And so it runs in a loop until it thinks it came up with the result, and then it spits out the answer. Predictive models, moving on. Totally different branch of machine learning. So these are not generative. This is more classic ML classification. And so the typical example from the TV show Silicon Valley on HBO, here's a photo of a hot dog. Is it a hot dog? Yes. OK, great. Predictive models work by basically taking an input and giving you a probability distribution over a range of set outputs, which is amazing for transaction classification. And so if you have a chart of accounts, you can take the input transaction description and go through, oh, how should we book this transaction? British Airways, airfare, great. Bunch of things here. Predictive models dramatically outperform all LLMs at predictive problem spaces. Bookkeeping transactions is not a generative problem space. You don't want the model hallucinating the transaction, making up a chart of accounts entry, et cetera. And there's some interesting stuff happening here. So you see all the blue bars are all the LLMs out there. This is a broad benchmark across a ton of transactions. And GPT-5, if you notice, is right in the middle. I know the text is a little bit hard to read. Generative models don't get smarter at predictive tasks the bigger and smarter the model is. And you've noticed they're all plateauing right below 80% accurate, right below how actual outsourced human accountants performed on this benchmark. And what's fascinating about that is this is what represents how the models are trained. Generative models are trained on the entire breadth of accounting knowledge on the internet. They know nothing about your specific client, their geo, their industry, their supply chain, everything that makes that business interesting. And that's the same thing when you work with, of course, an outsourced team that isn't familiar with that business. This is a far cry from what you see with dedicated accountants who know that client, know their books, know how to book everything. You get, of course, close to 100% accuracy. And that's what you're able to achieve with layers of predictive models. And so one of the key points here is use the type of model that is applied to the problem you're trying to solve. Go through the steps you would use to solve that problem and pick a model architecture that mimics that approach. Document extraction. All right, you're all probably familiar with this. It's been so many years of OCR and all the pros and cons of that. and okay, I really want to read an invoice and extract all the data, but with OCR you need to have templates and label the fields, and it's always iffy and makes mistakes. Document extraction models have basically solved this. You can now combine OCR with a technology called layout-aware language models. These are trained to understand document structure. And so the holy grail for years was, oh, can you pull the line items out of an invoice? Yes, today you now can, extremely accurately. Finally, data analysis. All right, this is amazing, right? We've done the full analysis. It tells me exactly what changed in the books, all the way down to the vendor level attribution, month over month, year over year, year to date, et cetera, et cetera. Oh, wait, what? All right, well, what's going on here? I'm hearing that this is just an equation. And so, yeah, okay, delta's not that hard. You probably don't need an AI to do this. Data analysis is just math. And yes, I could have an agent do this. I could give it a tool to analyze the finances. That would be extremely slow, extremely expensive to run, and it would probably hallucinate a whole bunch of the results. So the key takeaway here is AI is another name for machine learning. If people are talking to you about AI and they're not referring to machine learning, it is just BS. And I am not aware of any AI technology that would help you analyze a financial report. So if you hear that on the show floor today, please ask for more details. Why would you use AI to do a math problem? So that is 4 models and a lie in 5 minutes.